been working on with animals and silvopasture forages in Blacksburg.
Thank you for that introduction. I hope I don't disappoint. It's kind of nice to follow Dr. Fike and Kelly. Kelly, of course, was a nice segue into what I'll be talking about, the animal side of things. And Dr. Fike used half of my slides, so you've already seen. But this will just be a review for you. So we've been studying these 20-year-old hardwood silvopasture sites in Blacksburg, Virginia. So this is 3 hours west of here, higher elevation, cooler in the summer, a lot cooler than here. So keep that in mind when you see these differences. In addition, we're working with sheep, which these systems are small, so they were designed for sheep instead of cattle. But the idea was that sheep are kind of a good proxy for cattle, and just we're constrained by land unit size, so we're using sheep, but probably the same relationships would occur with cattle. So here are our sites here. This is a replicated system that was set up in an existing pasture about 20 years ago. We compare conventional open pasture on the left to two different types of silvopastures. These are hardwood silvopastures, and they've been thinned. They were originally planted in 8-foot spacing, 40-foot rows, and then 8-foot between trees. And now they've been thinned to about a 40 by 40-foot spacing. And you can see some of those stumps. They were left to regrow in between the trees, and those have actually turned into a pretty valuable feed resource. So it's nice that they weren't killed or ground up when they were thinned. So both of these trees were chosen in part initially for their phenology. Both trees leaf out relatively late in the spring compared to other trees, and lose their leaves relatively early in the fall. And of course, our cool season forages, which is what this pasture is composed of, their peak growth occurs in the spring and the fall. So you have this complementary, these growth seasons that complement each other with the forages and the trees. Black walnut trees also produce timber and nuts, and these millwood honey locust trees produce browse from the stump regrowth, and also edible pods that are similar in nutritional composition to whole ear corn. Some previous research has shown. So the management goal of these systems is to maximize those positive interactions, such as complementing the phenology or the growth habits of these systems, so that productivity is maximized. So I want to address one part of the productivity of silvopastures, and that is the animal production side. Here's an example of a real-life silvopasture in Missouri, and the black bars represent the deviation in the silvopasture from the control system, which is the green line. So I'm saying the green line is 100% productivity, that's our control, and then the black bars are the deviation of the silvopastures compared to our control. So they found, and this is similar to research that Kelly has shown, that there's a 20% yield loss in the forages underneath the silvopasture systems. In this case, it's a pine and walnut silvopasture and ryegrass underneath. So you can see that here. There's 20% less forage in the silvopasture. However, they found that there was more forage protein, and unlike Kelly's research, they found a little bit less fiber within the silvopasture forages. So these more nutritious forages compensated for the reduction in the amount, and so that partially led to equivalent animal gains within the silvopasture. There's no difference here compared to the open pasture system in total animal output. So in addition to the products provided by the trees, the animals are still producing the same amount. In Virginia, researchers also found that the forages in this case, black walnut, honey locust trees, were reduced in growth by, again, about 20%. But this time, there was no difference in forage protein level, and there was actually more fiber in the cool season forages underneath the trees. So there was less forage, and it was less nutritious, and yet somehow the animals, in this case sheep, still gained the same as animals in the control. So something else besides just forage characteristics is driving animal growth. And so the question is, what is that? And what we've focused on is perhaps the benefits to animal comfort and the cooler temperatures within the trees. So what's the impact of cooler temperatures on animal performance in an extensive setting. I think we know pretty well what would happen in a dairy or a confinement operation, but what happens in an extensive pasture situation. So one of the first studies on this was done in Oklahoma, and we've got different types of shade: abundant natural, a little bit of natural shade, and then artificial shade structures. And here's the difference in temperature from the control, so just the full sun. So negative temperature means it's cooler, all right? So the more negative it is, the cooler it is. And sure enough, within the abundant shade, it's cooler than within the scanty shade, okay? Makes sense. We can talk about it later, why this might be, but the artificial shade also is not as cool as the abundant natural, and there's something going on there with evapotranspiration of these living trees, and also just effective radiation that's absorbed by the 3D structure of trees versus just a 2D structure, so to speak, of an artificial structure. But what happens to the animals? Again, these numbers are the difference compared to our control. So in this case, a positive number is good, right? We want more gain than our control. And all these numbers are positive, so shade certainly is helping. And it tends to help both cows and calves when there's more shade than not. So there is a difference, and it shows up in the research. And I would argue that particularly in the southeast in Virginia, such as a place such as this, heat stress is a compound problem. And so that means that there's different factors that are exacerbating the problem, making the problem worse. And so I've got a kind of an interactive slide here. I hope it works. But I want some feedback from you. What do I mean by that? And we've touched on it a little bit. What's making cows hot? Any input? Okay, toxicity from the fescue. I'm going to see if this works. So I'm going to.
Black cattle get hotter.
All right, I'm going to. Okay, slow down. This is fun. I'm going to click on the fescue. Oh, yep. Perfect. So certainly the fescue, which there's this fungus that lives inside of it, it produces a toxin which constricts blood vessels of cattle, and so they can't get blood to their extremity and dissipate heat as effectively. So yeah, this is certainly making the problem worse. Most of our pastures in Virginia are infected tall fescue pastures. You said black cattle get hotter.
Black is hotter than a light color.
That's right. Black is hotter than a light color. So I'm going to click on this black cow. And sure enough, yeah, black cows absorb more radiation. They are hotter. And we've been transitioning most of our cattle to black Angus. What other issue is making this worse? Lack of shade, okay. And how's that happening? Or why do we have a lack of shade? Yeah, that's great. So you can't see it here, but there's a riparian buffer right there. And so we fence the cattle not only out of shade, but out of what? Out of water. So that's a good thing for environmental purposes, but what have we just done to our cows? We've stuck them all into the open, and so now what they do is they try to get up as close to that fence as they possibly can to get out of the sun, and you start to get this fence that starts becoming a walling point. So this is what you begin to see. You can see, or maybe you can't see, but just a wallowing point in the few trees that remain that they still have access to. So yeah, excluding cows is making the problem worse. And so there's one more piece of the puzzle. Well, just climate, right? So just whoops, didn't work. So just here's the average temperatures in Virginia, and in the summer it's hot. We know that, and also it's hotter now. We don't need to talk about why, but it's hotter now than it was maybe 5 years ago. So this is making the issue worse in Virginia. So I want to focus on one of the more popular, or one of the more focused on issues here, fescue toxicosis. One of the issues, or one of the solutions or ways we can mitigate this has often been, well, let's dilute it with something else. Let's give the cattle something else to eat, and one thing would be to dilute it with clover. And in this example, they diluted it with alfalfa. This is in Kentucky. And so they looked at the interaction of diluting the forage stand with alfalfa versus giving them shade, in this case artificial shade. So you can see here the forages, here's the diluted forages, and then whether they had no shade or they were provided with artificial shade. So just some general trends. Here's the average daily gains of the cows, calves, and steers in the different situations. And when the cattle were provided with shade on toxic fescue, they generally did better, at least in the case of the cows and the calves, better when they had shade. So there was a benefit there. And now it's interesting, when the forage was diluted with alfalfa compared to just tall fescue alone, but then there was no shade, they actually did a little worse. Probably there was no difference effectively, but certainly it was better to give them shade than to just dilute the forage standing with alfalfa. But when you use both strategies, when you provide them with shade and you dilute the forage standing with alfalfa, you get the best gains of all. So that kind of is evidence there that it is a compound problem, and there's different ways and strategies to mitigate these issues. You saw this slide from Dr. Fike a little bit ago. This is in those silvopastures in Missouri, and they looked at the interaction of just getting rid of the toxic fescue and replacing it with a novel endophyte tall fescue, and the interaction of that with the trees. And the same thing applies. You can provide trees to the animals on toxic tall fescue and get a big boost in productivity. And that is pretty similar to the boost when you just get rid of non-toxic tall fescue entirely, though this number right here, percent calving, is kind of interesting that it's lower when there's no shade, but they're on a novel endophyte tall fescue. I don't know that I would have expected that. But then the best situation is when you get rid of your tall fescue entirely and you add trees back into the system. So hopefully you all can see those trends pretty clearly here. And this is a really interesting YouTube video if you're interested on this presentation and the research they found. So I want to transition now back into our work in Blacksburg. And like I said, our hypothesis was that animal comfort is likely compensating for any changes in the forage characteristics. So the forage characteristics that Kelly's seeing, this reduced yield within silvopastures, maybe some less desirable nutrition. Somehow our animals are still gaining the same, so something else is driving their performance. So we wanted to document both the forage response and the animal response to silvopasture. Here's an aerial view of our study site. There are 3 treatments: the open pasture, black walnut silvopasture, and honey locust silvopasture. And throughout, I'm going to use the same color scheme. So black will refer to the black walnut silvopasture. Yellow will be the honey locust silvopasture, and green will be the open pasture. So you can see that in our layout here. And this is replicated across the site, gives us more statistical power. And for each of the summers, it's a 12-week grazing study. We used lambs, and we rotationally stocked these systems, so that's another point of these systems. They weren't just thrown in there. Yes, sir? The area, yeah, sorry, and that's in hectares. I'm sorry about that. What is that? About 2/3 of an acre. 2/3 of an acre. So one of these blocks is 2/3 of an acre, and they're all equal. So they're all treated the same. And we stocked them according to forage availability. So if there's less forage produced, we put in fewer animals. And that'll become important a little later. And so here's the starting weight of the lambs, and it gets smaller just because that's what we had available to us each year. And we had some parasite issues in the first 2 years, so we switched to a hardier hair sheep cross in the final year, this past year. Like I said, the pastures are replicated across the site, and basically we consider significant differences at an alpha of 0.05, which basically just means there's a 95% probability that it's a true treatment difference and not just an effect due to chance. For our methods, I'm just going to run through these. Raise your hand if I'm going too fast, but we documented forage height with a rising plate meter before and after every rotation. Every 4 weeks, we took a quadrat and we estimated the percent cover of each species at 12 points across each experimental unit. And that's every 4 weeks across the summer. And then we collected forages to assess their nutritive value, and we looked at neutral detergent fiber and percent protein. With regards to the animals, we weigh them every 28 days. We use little temperature loggers. You can see them here. They're set to log temperature every 10 minutes. And we inserted them into a blank seeder. So these are devices typically used to synchronize estrus and ewes. These don't have progesterone on them. And we put the device inside, seal them up with electrical tape, and then we can put them into the ewes where they log temperature remotely every 10 minutes. So we can collect core body temperature underneath trees. We took trail cameras and set them out in the systems for one day of each week to take a picture of each system every second. And then we used marking paint. You probably can't see very well, but there's a blue animal and an orange animal and a pink animal to document what behavior those animals were doing at any given moment and if they were in the shade or not. So speaking of shade use, and you've already seen this picture, of course, but speaking of shade, perhaps our most significant result was how much us researchers spent time in the shade compared to the open pasture system. But anyway, that's just a joke. I'm just saying it's enjoyable working in these systems. It not only looks nice, but it feels nice to be working in these systems. So here's the forage mass results, so the amount of forage in the different systems. Again, black represents the black walnut silvopasture. And in these systems, there was a 30% reduction in the amount of forage produced underneath the trees compared to our control, which is the green bar. And the different letters just mean that the treatment response is the same. And if they have the same letter, such as in this case, that means there's no difference between the treatments. And sure enough, in the honey locust silvopasture, there was no difference in the amount of forage produced. Certainly there's a lighter shade canopy there, and there might be some other factors influencing that. Here are the species, forage species associated with the different trees and the different systems. So the percent composition of a particular species is shown on the x-axis. So here at the top, tall fescue in the black walnut silvopasture, there's a lot less of it than in the other systems. Okay, do y'all catch that? In the black walnut silvopasture, there's also more orchard grass, more bluegrass, more red and white clover, but there's also more warm season grasses. So this is nimblewill and yellow foxtail, generally fibrous and not desirable, particularly by sheep. And there's no horse nettle at all, a toxic weed in the black walnut silvopastures. In terms of nutritive characteristics, there wasn't much difference in protein and neutral detergent fiber. It actually is very similar to Kelly's data. There's more protein in the silvopastures, but it's only a percentage point difference, so it doesn't really make a difference. The forage protein within the open pasture was adequate for lamb growth at all times. In the case of neutral detergent fiber, it's also just a percentage point difference, so there's slightly lower fiber within the honey locust silvopasture compared to the other two systems. So with these results in mind, we might expect that in the black walnut silvopasture, if we're just looking at forage characteristics, there's less forage and it's less desirable, so animals probably would gain less, or that would be my assumption going into this. Whereas in the honey locust silvopasture, forage production more closely resembles the open pasture, so the animals there probably gain the same as animals in the open pasture. Instead, when we look at the average daily gains across the 3 years, we found that the animals in the silvopastures do just as well or even better than animals in the other systems. So this is average daily gains, and if the letters are all the same, that means there's no difference between treatments within a year. So in the first year, the gains were low because we were working with larger animals, but they were equivalent for all systems. In the second year, we had parasite issues, so gains were low again, but still all systems produced the same animal output. And then finally in the third year, we actually had more gain for the animals within the black walnut silvopasture shown here by that black bar. You might recall, though, that I said we stocked according to the amount of forage present. So the black walnut silvopastures could only handle a certain number of animals or less animals than the other systems. So it's more appropriate to, instead of looking at individual animals, which is what this shows here, look at total system output. So what are each of these quarter hectare systems putting out in terms of animal gain? And when I do that, there's no difference in, or there's no interaction between year and treatment, and so I can lump everything together. And essentially, all systems produce the same amount of animal output. And in the case of the black walnut silvopasture, that occurred despite some serious issues in forage productivity. So this is telling us that something else is influencing animal growth. So that leads me to my comparison of animal physiology and behavior. So here are the body temperatures of the ewes in the different systems, averaged across all 3 years. On the x-axis is hour of the day, and then your vaginal temperature is here on the y-axis. So the animals within the deep shade of the black walnut tree, shown by the black dots, had lower body temperatures during the hottest part of the day. So here's the afternoon hours, and certainly they're cooler by about 1 degree Fahrenheit in those systems on average. There's a lighter canopy in the honey locust system, and so those animals are also cooler than animals within our control, shown at the top. But they're a little hotter than animals within the open pastures, or in the black walnut silvopastures. It's interesting to compare these points to the temperature humidity index, so the ambient conditions. This is the y-axis, and it's represented by the red line here. So here's nighttime, it's low, and then it rises up during the afternoon. And it's interesting to see that the animals in the silvopastures experience less fluctuation. Their body temperatures are more stable, whereas those animals in the open pastures, their body temperatures fluctuate more with ambient conditions. So there is a benefit here in terms of body temperatures showing up. Here's the behavior of the animals each day. And so the animals within the silvopastures, shown here, spend over 95% of the day in the shade. So if there was shade, they were in it. And if that shade moved, they would get up and they would follow it. They were very active in seeking out shade. The animals in the silvopastures also spent a little bit more time grazing, at least in the case of the black walnut silvopasture. And so that could be because of a lower forage canopy, or it could be due to more comfortable conditions that allowed them to graze more evenly throughout the day. Most importantly, the animals in the silvopastures spent more time lying down. The animals in the open pastures, you can see here, spend about 2 hours longer each day just standing up. And so that represents a couple things. It takes more energy to stand up than it does to lie down. And also, time spent lying down is a traditional metric of animal comfort. And although we didn't send out a survey to the ewes, we're confident from this that the animals were more comfortable within the silvopastures, just indicated by the amount of time they spend lying down. And here is some, I didn't talk about this, and actually this slide's kind of a surprise, but I'll just talk about it anyway. We've documented their grazing behavior, how many bites they take per minute, and so here's just some preliminary results. So bites per minute is on the x-axis. This is one animal in the black walnut silvopasture. This is an animal in the honey locust, and this is an animal in the open pasture. And the animals in the open pasture graze more, a little bit in the morning, and then they just kind of stop and stand there trying to dissipate heat. And grazing doesn't really pick up until about 7 p.m. when the sun's gone down. Animals in those silvopastures, the temperatures are more comfortable throughout the day, and so there's more opportunity for them to graze evenly throughout the day. So you've seen this slide, and so just to recap a little bit of what we've talked about. In the black walnut silvopasture, the amount of forage is reduced, and there's also less desirable species. But these issues are likely compensated by the benefits to the animals in terms of their body temperature and their behavior, such that the animal output of these systems is the same. In the honey locust silvopasture systems, the similar forage productivity coupled with those slight benefits in animal comfort also led to equivalent gain. So these systems are producing the same amount of animal output plus whatever products are provided by the trees. And this is just a summer project, of course. But our data indicate that silvopastures can increase land productivity when they're incorporated into our cool season forage-based livestock systems. And thank you. I'd be happy to take any questions or discussion points. Are we good to go? All right. Yes, ma'am.
Just curious, with the black walnut, that's a really valuable wood. At what point are people looking to harvest those for sale in this situation?
In this situation, yeah. So the question is, black walnuts are valuable trees in terms of timber, and so at what point are they looking to harvest these trees for that purpose? My guess is 40 to 50 years, I think, is the typical rotation. More? 60 to 80 years on good sites. Yeah.
Well, on the locust, what do they do with that?
What's the purpose of the locust? Yeah. I don't think there might be a specialty market for honey locust, but I don't think it's significant in terms of timber. But firewood, fence posts. I think from an animal perspective, one of the biggest advantages in my perspective is the pods. So those pods, in this case, they're a grafted tree, so they produce an extra big pod. It's thick, and it's filled with sugars, and those fall in about October, November, which is right when forage production is starting to decline. So there's a perfect energy complement to our high-protein tall fescue stockpiled in these systems. So it's a nice way of balancing out the diet and extending the grazing season. So it would be interesting to look at these on a whole year basis when you've got the pods and the summer benefits. Yes, sir.
You kind of hit on a little bit. I guess this question could be directed to everybody that's already spoke today. So far, we've gotten a lot of information that the silvopastures is great for your forage, it's great for your livestock, but is this a symbiotic relationship with the forests? By putting the livestock on there, is there any research that's gone into tree health, forest health, site production, soil health? Are we getting nutrient? Are the nutrients not being able to filter as low? Are they getting intercepted? Or for people that are in the south side, that we work a lot with the pine trees. The site productivity is what is key. Is this going to slow down our pulpwood, or if someone wants to manage for solid timber versus in pulpwood, are we going to get slower growth rates? I know as the Department of Forestry, a lot of our guys are all about fast-growing trees. If we take these trees that we've engineered to grow fast and we stick them in silvopasture operations, are we going to get a lower site index year after year as more animals are on there? Is the forest health going to be affected by this? How is this going to relate to forest versus animals?
Yeah, that's a great question, and it is what we've talked about the animal and the forage side, but what's the effect on the trees? And I think and hope that there will be some more input from the forestry professionals.
Well, we can have that discussion now. We've got some time for that discussion. So I'd ask our foresters to stand up because I'm not a forester. So Tom, Todd, Greg, I'm calling people out because of the
Go ahead, Sid. I've been a forester. Well, but you don't have to be a forester to have read the literature or to have seen the results. And depending on, I think how the systems are managed, there is evidence of greater tree growth in these systems because they're not all in that kind of competitive environment. You do, particularly like if I've got alleys, then I've got greater light resources into those trees. And if I'm putting nutrients back into the system, or if that animal's recycling nutrients back into that system, those grasses don't capture all of that. And so, I'm pulling that legume up, I'm digesting it. I'm not a sheep, but if the sheep's doing that, digesting it, and it's, urinating it back into the system, some of those nutrients are going to go, and they're going to get below that grass root zone, so that tree has an opportunity to capture some of those nutrients as well. So, I think there's potential for greater productivity, and I think Sid has had some experience with that. Go ahead.
I'll touch on that after one too. Just colloquially, I don't have research papers.
In your experiments, it looks like the pictures seem relatively flat. What happens when you're in a rolling situation in terms of erosion from the cattle or the...
You mean that where our pastures are flat.
Yeah, in the pictures it looks that way. Maybe that was just a.
Yeah, that may just be a bad shot. These are pretty significant slopes.
Go back to the very first slide, where you have the three side by side. That might be more of a value.
Yeah, these are actually have a little bit of slope on these.
Okay.
See that
Yeah,
slope?
yeah.
Yeah, I'm in my best shape during the summer months.
And
But-
see, I've actually suggested that with silvopasture, you could improve the or reduce the potential for soil erosion and water quality issues in hardwood stands. I don't know about you, but a closed canopy hardwood stand on a slope with no cover on the ground is soil erosion. I mean,
Right.
that was something I hadn't seen until I'd been in the Midwest for a while. But just because you've got a good cover of trees on a sloping ground doesn't mean that you're holding the soil. And you can actually, by getting some cover on the ground, you can improve conditions. So there's obviously, a chance you could make things better. The one thing I guess I'd emphasize is that if the grazing is done right, there shouldn't be site degradation. Shouldn't be getting compaction, roots being crushed, stems being damaged if the grazing is managed properly. I can remember years ago reading a study from Oregon about ponderosa pine plantation, and they were putting cattle into young plantations while the seasons were very short, but they found as long as the forage was in great condition, the cattle are not going to be clipping buds off of pine trees when there's good grass to graze. So as long as they got the cattle out before the forage declined, they weren't getting damage to the trees.
I would also just point out that I would also come at it from the other side. Having the trees well distributed also increases your chance of having good management, because those animals, when they don't just have this solitary tree that they're going to be wallowing under, they're able to use and distribute nutrients more evenly across all the site. Yes.
Just
Yeah.
to add to that, it says, first time I saw this as a forester, I went, wait a minute, this is backwards. We don't put, and it goes back to what John Pike showed, it's not turning cattle loose into the woods. So it's the distribution, it's the timing, and it's not the leaving them there. So that rotational thing is key. And soil types too.
So one slide that was missing from John's presentation that he almost always shows was that land equivalency ratio slide. You didn't show that this morning, did you, John?
No, I didn't show that.
Yeah. So can you just tell everybody what that is, what that slide shows? You don't have that slide.
Well,
I've got a similar
he was talking about
similar one.
something similar there. And what you're essentially talking about, if all I can get off this land base is cattle, I've got a kind of an upper threshold of what I'm going to be able to get out of that land. If I'm using that land simply for timber production, then I've got an upper threshold. There's some limit, some biological limit of what kind of productivity I can get. And so when you're looking at this kind of mathematical description, we call it the land equivalency ratio or land equivalent ratio. If you look at the last bar, the silvopasture, that land equivalent ratio is greater than 1. And all that's saying, so if I'm looking at, again, starting from the left, the pasture productivity, I got an upper threshold. Pine plantation or some sort of forested habitat, I got an upper threshold. I put them together, I might actually depress some of the components. But when I sum those up, the sum of the components up, the total yield on that land base is greater. And what Gabe's data are showing us is that we don't necessarily have to take a hit on animal productivity, and we're adding the tree component back into the system. So the land equivalent ratio, we are getting more product off that land base, and we have potential for greater conservation services in terms of nutrient utilization, efficiency, reduced runoff, those sorts of things. Does it come easily? Probably not. Does it require management? Most certainly so. But what we're saying is we have the potential to use this thing here along with our other tools to get greater resource use and greater conservation out of our landscape.
All right. So
A good comment I heard once John said at a workshop was, don't even bring this up with someone who's not already a good manager, because it is so management intensive. It won't work if you're not a good manager.
There's a question in the back.
From the forestry standpoint, I would echo many of the things that have been said. A lot depends on objectives, dedication to management. It's pretty complex and not easy. So, and a lot depends on your species, your trees you're looking at, your sites, your soils, how they're managed. So there are no really easy answers for either one. But I think John's last comment was good, that with good management we can do good with both.
And I would add, Dean, I would say it's not easy, but I think there are tools and tricks that we can utilize to limit the heartburn for some of these things too. For example, I didn't show a picture of this, but there's a producer in Charlotte County who had a pine stand. He just went in and cleared out alleyways or corridors within that, and he left rows of 2 or 3 pines, and then he got forages within that. I wish I had the economic response on that, because I don't know exactly what that's going to look like. But the trees look good. We were there
Months ago,
2
maybe?
months ago, probably, just about right at 2 months. And the trees look good. The forages look good. His cattle seem to enjoy that environment. So that's a different way than, say, this kind of orchard style that Gabe's data looked at. So there are different approaches, I think, that can facilitate implementing these systems.
Yeah, I'll jump in since John and Chris have both kind of called me out now. But, say you're looking at pines, we don't have these studies done over long term yet to be able to track the growth rates and everything, but we can model it. And there have been, based on models that have been created from biometric equations across the southeast at pines at different densities. And what you see when you run those models is your overall timber volume. And if you're just looking at volume, and I know you were asking also about quality and things like that, the overall volume per acre is going to be less. Per tree, it's bigger because each tree has less competition with other trees. So potentially, if you're in an area where you can take advantage of different markets for higher value products, that could possibly bump your value up a little higher. But that depends on the markets in your local area. You also asked about quality, and I think there are some issues that need to be managed there. And I think part of it is the roots and managing the grazing so that there's less impact on the roots. But you also have to consider branchiness, and if you're thinning like a hardwood stand, you're thinking about epicormic branching and how to deal with that, or if you're even going to bother dealing with it. And with pine trees, if they are grown more open, they're going to need more branchy lower down. And there's different strategies. Like John said, we have to use our noggin and figure out, how can we plant those trees in rows so they're limiting each other's branching a little bit and self-pruning. Or we're going to think about, the labor involved with pruning, that kind of things like that.
Well, you asked how long to get a walnut tree, and I don't know, how much of that matters to this crowd in terms of when am I going to harvest that. That's one of the questions I often get. Well, or it's not even a question, it's a statement. I'll never harvest that tree. Why would I plant that thing? Well, you may not spend all the money in your bank account before you die. But you'd like to see your bank account growing on the way out, wouldn't you? So you're going to pass that on to somebody. It's going to have value. And none of us gets out alive. So, why are you worried about that question? If you're thinking about managing these systems over time and somebody else taking them. I think one of the challenges really for these systems is that much of the land that's managed is not under ownership. And so working out relationships where the landowner is willing to invest in or to put up with this kind of long-term scenario is probably going to be whole nother social issue, but I mean, I think that's another, potential roadblock to implementing some of this system. Yes?
When we look at that canopy for your livestock, what value would a sawtooth oak have? It grows quicker. Anybody familiar with that farm? I know sawtooth oak.
Acorns are big, and so possibly, I don't know, have cattle or something, but other wild animals love these.
Yeah.
It's a canopy quicker, so it'll be a shade there for your livestock. Wildlife like it. I mean, I haven't heard anybody say anything about sawtooth oak. And then you're looking at your canopy and your shade for your livestock.
Acorns could be bad, yeah.
Okay. That's good. That's the color.
Well, yeah, and if you had pigs or something like that, acorns may not be, acorns may be something you want. I'm not sure acorns are, I think that a lot of times we get into these toxicity issues, people are worried about, that tree's, black locust is toxic, right? But here I've got a producer that's using it. I think a lot of times we get into these toxicity issues where we have overgrazed something and animals don't have anything else in the diet, so then they load up on something that's got toxins in it, and they die, and we say, oh, well, that's terrible. Well, there are a lot of people in this room that will drink a beer tonight, if they get an opportunity. And I say, well, that's toxic. You're going to do it. And you say, well, yeah, but I had salted peanuts and some other pretzels with it that was good. Okay, so think about it in the context of the whole, not just as a single entity for your whole entire, your caloric intake.
There has been some work with oaks. Dr. Fikes planted some oaks, and I think others have as well. I think the challenge, from my perspective, is that complementarity that I mentioned before. Oaks leaf out relatively early, at least compared to our other trees. So you've got a denser shade and a larger canopy in many cases.
Yeah, I'll just say, I think that's an interesting idea. I don't think any of us here had thought about
Alan
sawtooth
had a
oak.
question.
I don't know that it's particularly valuable as a timber tree, but maybe that's something to explore with an individual producer if they have use, if they want to do something with pigs and want to use those acorns or something. I don't know. Maybe that's one of those different kind of tree that's a little bit not what would be like a standard option for a large scale producer, but maybe a specific small scale producer.
And there's lots of species that like acorns. It's hunting season right now, and we're all looking for acorns. Dr. Franz-Luber?
I was just wondering about, you had actually a modified continuous grazing system, right? Because the animals weren't really rotated, or were they?
They were rotated.
They were?
Yes.
Okay, but I thought you had adjusted stocking based on foraging.
Yes. So
Set stock, but we started the study with different stocking rates.
Different seasons. Right, and could you also tell me how many trees per acre it would be equivalent to? Was it the same in both systems?
it was the same between black walnut and honey locust systems. Trees per acre, is it 100?
No, I think it's more like 40. I think it's about 100.
Oh, really?
Yeah. Actually, maybe a little less than 40. I have to go back and refresh my memory on that. That's after it's been thinned. It's been thinned, yeah. That's the final deal.
All right, one more question for Gabe and Adam.
Strange one coming from a forester, I suppose, but why are sheep a good proxy for cows?
Well, they're both ruminants, so there's a similarity right there. In fact, I think typically we'd say that sheep or at least the hair sheep are generally more heat tolerant than cattle, and also more fescue toxicity tolerant than cattle. So if anything, we might expect more extreme numbers with cattle in these systems. But they've got 4 legs, so that's maybe.
All right. Let's give Gabe a big hand.